Hello everyone, my name is Vijay. I am from CSIT. Today my topic is machine learning for 6G wireless networks, carrying forward enhanced bandwidth, massive access and ultra reliable or low latency service. From the subject image processing. Introduction. To satisfy the expected plethora of demanding services, the future generation of wireless networks 6G has been mandated as revolutionary paradigm to carry forward the capacities of enhanced broadband, massive access and ultra reliable and low latency service in 5G's wireless networks to a more powerful and intelligent level. Recently, the structure of 6G networks has intended to be extremely heterogeneous, densely deployed, and dynamic. Combined with tight quality of service, such complex architecture will result in the untenability of legacy network operation routines. In response, artificial intelligence, especially machine learning, is emerging as a fundamental solution to realize fully intelligent network orchestration and management. By learning from uncertain and dynamic environments, AML enabled channel estimation and spectrum management will open up opportunities for bringing the excellent performances of ultra broadband techniques such as terahertz communications into full play. Additionally, challenges brought by ultra massive access with respect to energy and security can be mitigated by applying AML based approaches. Moreover, intelligent mobility management and resource allocation will guarantee the ultra reliability and low latency of services. Concerning these issues, this article introduction and surveys some state of the art techniques based on AML and their applications in 6G to support ultra broadband, ultra massive access, and ultra reliable and low latency services. Recently, the 5G wireless networks was developed to support enhanced mobile broadband (EMBB), massive machine type communications (MMTC), and ultra reliable and low latency communication (URLLC). According to the report of the International Telecommunication Union, benefiting from such high performance 5G has been opened new doors of opportunity toward emerging application. Example: augmented reality, virtual reality, tactile reality, mixed reality, and so on. However, the new media, such as holographic communication, will require much higher transmission speeds, up to te- terabits per second, than AR and VR. Thus, 5G is far from able to support the faster, more reliable, and large scale communication requirements of these services. In carrying forward enhanced bandwidth, more reliable and large scale communication requirements of these services in carrying forward enhanced bandwidth, massive access and ultra reliable low latency service response, the navigation of future generations of wireless networks 6G has been triggered, which promises more powerful capacities in terms of ultra broadband, supermassive access, ultra reliability, and low latency than 5G does to provide ubiquitous and various services. 6G networks tend to be more comprehensive and multidimensional by integrating current terrestrial networks with space or air based information networks and marine information networks. Then heterogeneous networks resources as well, different types of users and data will be integrated as depicted. According to such architecture, 6G networks are conceived to be cell free, which means that users will move from one network to another seamless and automatically to pursue the most suitable and qualified communication without manual management and configurations. On the contrary, current 5G networks technology still mainly focus on a macro and small cell based heterogeneous architecture which will be broken by cell-free operations of 6G, and their performance will deteriorate when applied to 6G with brand new architectures. In addition, how to manage and control 6G networks to realize the promising capacities of ultra broadband. Ultra massive access and ultra reliability and low latency also poses great challenges brought by increasing ultra dense, heterogeneous and dynamic characteristics. Especially different kinds of satellite internet consist of large number of satellites were proposed and implemented in recent years. For instance, the SpaceX internet consists of large number of satellites were proposed and implemented in recent years. Um, Plan to build a constellation of 12,000 satellites in low Earth orbit, which has been expanded to 42,000 recently. In addition, mobile networks operations are accelerated. The dense deployed of small cell-based stations to 42,000 recently, also bringing challenges of spectrum management and massive or super access control. Furthermore, the integration of highly dynamic satellites, unmanned aerial vehicles, UAVs, and the Internet of Vehicles will be result in more frequent handovers, more uncertain users, and unpredictable wireless communication environments. Here, there is an AI-enabled functions. Um, we can see automated service, distributed service provisioning, performance evaluation is changing into smart city, smart industry, intelligent transportation, and everything. This comes under smart application layer, and then intelligent control layer, parameter optimization, task scheduling, policy learning, resource management, and then data mining and analytic layer, diminution reduction, abnormal data filtering, knowledge discovery, feature extraction, intelligent sensation layer, data collection, statue detection, environmental monitoring and measurement. Intelligent broadband transmission in 6G. In the bandwidth hungry age, 5G networks have exploited the spectrum bands of sub gigahertz and 1 to 6 gigahertz as efficiently as possible by introducing 24 to 100 gigahertz. However, the current spectrum bands are still hardly enough to meet the increasing demands. For instance, some emerging applications such as holography may require a data rate of up to terabits per second, which is three almost three orders higher than the typical 5G communication. In response, terahertz communication utilizing bands in the range of zero point 0.1 to 10 terahertz as well as 140 to 220 and 340 gigahertz frequencies as expected to support the data rate of up to terabits per second. To achieve such a capacity, approaching performance accurate information of time varying channels is especially important to optimize terahertz bandwidth allocation and improve spectrum efficiency. In the section E, we introduce some of state of the art AI or ML application, the terahertz channel estimation and spectrum management. Dynamic spectrum allocation. A distributed spectrum allocation framework also can be formulated based on multi-agent DRL, in which the agent refers to each device occupying the spectrum's resources. In such a framework, the multi-agent environment is established as a partially observable game model. To deal with the instability of the environment, a neighbor agent actor critic model NAAC, which trains the information from neighbor nodes in a centralized manner but with a decentralized implementation, can be introduced to leverage the relationship among devices sharing the spectrum resource to improve system performance such as some data rate and spectrum efficiency. According to such a framework, the historical information is used for training the RL model but not the decision of spectrum allocation. AML based energy and security management for Super IoT. 5G cellular networks introduced a new usage scenarios oriented to support massive IoT, namely MMTC towards 6G. The concept of a super IoT has been proposed recently, which can be elaborated with symbiotic radio and satellite assisted IoT communication to support an astonishing number of connected IoT devices and an extended coverage, respectively. Consequently, more efficient energy management mechanisms are expected to support the large scale of IoT systems to operate stably for long periods of time. In addition, privacy and security issues will face more severe challenges, especially for IoT system collecting individual or sensitive information. This section introduces AML enable energy and security management in super IoT systems. Central is online AML based management. In contrast to offline management, online AML or based energy management approaches only require the present and previous energy levels and channel statuses with when implemented to improve the communication performance in energy harvested enabled super IoT systems based on the online AML framework. Power allocation and access control problems can be established as stochastic control problems whose discretized energy and channel states are then modeled as MDPs. However, this online AML framework still requires the perfect information of energy levels and channel status, which is hard to observe in practice. The RL and Lyapunov optimization based methods emerged as a result, most of which searched approximately solutions in a centralized fashion. And nevertheless, this centralized approach is not applicable when the number of IoT devices is large, resulting from inevitable significant feedback overheads. In addition, MDPs always suffer the curse of dimensionality, which results in heavily computational loads and makes MDPs intractable. AM enable ultra reliable low latency application satellite UAV and IOV communications will be integrated in 6G networks, for which the high dynamic of channel environmental and traffic as well as increasing delay sensitive applications require more reliable and low latency transmission technologies to guarantee communication connectivity and timelines. In addition, accompanying frequent resources allocation, network reconfiguration and service customization also depend heavily on reliable management. To satisfy such needs, mobility management and offloading techniques are expected to support ultra reliable and low latency communication, and also are confronted with challenges brought by high dynamic, multidimensional, and significant heterogeneity.